This is the brief on the mathematical identity that lets physics actually work, even when space gets all warped. We're diving into how a really precise mathematical relationship gives us the exact tool we need to fix distorted measurements, especially when we're looking at vector fields in these super curved coordinate systems. Okay, so first, here's the problem. When you're working in curved space, your coordinate grid itself is warped. And that means any simple, naive calculation you try to do, like measuring a vector field's expansion, it's just physically meaningless. It doesn't work. So how do we get a real, true measurement? Well, second, you have to apply a very specific correction. It's called the covariant divergence. And the key ingredient is something called the Christoffel term. Think of it as this dynamic factor that accounts for just how bent out of shape your coordinates are. And finally, you might be thinking, that sounds like a huge pain to calculate, right? But this is where a key mathematical identity becomes a total game changer. It comes from the metric tensor, which basically defines the geometry of that space. It gives us this beautiful shortcut, an exact formula that lets us calculate that tricky correction term. Suddenly, the whole problem becomes totally manageable. So in the end, it's a specific mathematical identity that's the absolute key to figuring out physical expansion when space itself is curved.